Very good morning, my dear friends. Myself, Professor M.H. Annaya, and friends, in today's video, we are going to design a welded joint which is subjected to a pull P. And here we are required to find out what is the length of the weld required. So in this sketch, it has been given that a MS plate 50 wide, width of this plate is 15 millimeter wide and 15 millimeter thick, is to be welded to another plate. This is second plate, plate 1, this is plate 2, by a single transverse. Transverse weld means a weld which is perpendicular to the load axis. So this is a single transverse weld, and these two are parallel weld. So there will be double parallel weld and a single transverse weld which is subjected to a load P. And we have been asked to determine the length of weld required when there are two cases. Number A, the load is static, there is a static load, and B, the load is dynamic. Load is dynamic. Dynamic load or fatigue load, they mean the same. Friends, whatever the load we have here, that is being shared by this total weld, that is by the transverse weld, which is also called normal weld, and these two parallel weld. So we can commence the problem by stating that the total load P is the load shared by, is the sum of load shared by transverse weld plus load shared by parallel welds. Friends, first of all, you should know what is the total load, because I have not specified what the total load is. Friends, we have this plate, this rectangular in cross section with width 50, thickness 15. You will get the area of this cross section of the plate that is being welded. And if you know the tensile stress of the material, you can find out P. Therefore, P is equal to area of cross section of plate multiplied by sigma tensile. So area of cross section, friends, is the product of B into H. H is 15. This is the area of cross section. And the tensile stress, they have not specified in the problem. So friends, if you refer to machine design data handbook for this transverse load, we have the sigma t value equal to 110.3. 110.3. Friends, if you multiply these two, you will get the total load, that is the value 8272.5. 8272.5. 8272.5, sorry. This is the total load the plate is being subjected to. So this is the first step. Now friends, we will put this value here and see what are the loads shared by the transverse and the parallel welds. So friends, on the left hand side, I am going to substitute 82725. 82725, that is equal to load shared by transverse weld or the normal weld. You know, transverse weld failed by tearing, and you have the formula sigma T is equal to P divided by 0.707 H into length of that transverse weld. That is L2 in this case. Friends, if you cross multiply here, you will get this sigma, the load shared by this is, by the transverse weld is 0.707 H into L2 multiplied by sigma tensile. This is the load shared by the transverse weld plus the load shared by the parallel weld is given by the formula on the same lines as 0.707 into H. The thickness remains the same into twice L1. In place of length, I am writing L1 plus L1 is the total length of the parallel welds multiplied by shear stress tau. Friends, we make use of the same formula or the same statement for both static and dynamic load, but in case of dynamic load, we are going to divide the sigma t and tau by the corresponding values of fatigue stress concentration factors. Now this is the first case, that is case A. It is for a static load I am taking. For the static load, this is the equation we have got here. We can substitute the values here, friends. 0.707, thickness is 15, multiplied by L2. What is L2, friends? If you see the diagram, L2 is generally equal to width of the plate. This you have to remember very well, because without knowing this concept, you can never solve this problem. That is into 50, I will write down. That is 0.707 into H into 50 is that length, which is equal to B, multiplied by sigma tensile 110.3 plus this equation, load shared by the parallel welds, 0.707 into H is same into L is twice L1, where L1 is unknown, and the shear stress value is given to be 75.8 obtained from machine design data handbook. Friends, in this expression, everything is known excepting L1, which is the length of each parallel weld. So we can say, after simplification, therefore, length of each parallel weld, length of each parallel weld, that is L1, works out to a value 15.08 millimeter. Friends, as usual, you have to add 10 millimeter extra for starting and stopping of beads. Friends, after knowing how to obtain the load or the length of weld required for the parallel weld, let us take up the second case, that is case B, when the load is dynamic. Friends, I told you in the beginning of this session that we are going to use the same formula as we have done for the static load. That is, we are going to write total load P is P transverse, load taken by the transverse joint plus P, the load taken by parallel weld, transverse weld, parallel weld. Sum of these two is the value of P. Friends, this P we have calculated as 82725. What is this P transverse weld? It is nothing but 0.707 into H. It is transverse into L2 multiplied by transverse tearing sigma tensile and plus this is 0.707 h into twice L1 multiplied by tau. This is for the static load. If it is dynamic, friends, this value of sigma t is to be divided by the factor 1.5 here and this shear stress by 2.7. So these two values are the fatigue stress concentration factors and are obtained from machine design data handbook if it is not specified in the problem. Friends, you know very well in this L2 may be approximate as B, which is equal to 50 millimeter. That is given in the question, and hence you will be able to find out, you know, the value of tau. You know sigma t. The sigma t is 110.3 and tau is equal to 75.8. So if you make the substitution, friends, you are going to obtain the length of each parallel weld, that is L1 equal to 71.46. So you will get L1 is equal to 71.46 millimeter. And friends, finally you will have to add 10 millimeter extra for starting and stopping of beads. Friends, I hope the presentation was interesting. Please go through the complete video and share this video with all your friends. Have a wonderful day, and I thank you very much for watching my YouTube video.